My dear students, can you hear me?
Exactly.
Yes, sir.
First of all, can you see the screen?
Yes,
Yes,
sir.
sir.
So my first question is, how is Newton's first law derived from second law? So very easy, it is well known to you also, because in your previous class, I mean SSC section, secondary section, you have done this in very well, but I am repeating again. That is, how is Newton's first law derived? From second law. So from second law, we know F equal to ma. So according to first law, this force this force is zero according to first law. So ma equal to 0. That means a equal to 0. Since a equal to 0, that is v minus u by t equal to 0. That is v minus u equal to 0. That is v equal to u. That means if initial velocity becomes 0, that is rest, then final velocity will also be 0, rest. That means a body at rest want to be at rest forever if no force is applied here. And if u is 2 meter per second, for example, then v will also be 2 meter per second, because u equal v equal to u. That's why, since u equal to 2 meter per second, v will also be 2 meter per second. So that means a body in motion want to be in motion forever. So that is the first law. First law from second law. First law is derived from second law. That's enough my side, from my side. Anything from your side to ask me something? Okay, you have nothing. Thank you so much. You are very good. My next question is, how is Newton's second law derived from first law? So, according to first law, according to according to first law, F equal to 0. That means force, because what was the first law? A body at rest want to be at rest if no force is applied. That means if force is 0, that is according to first law, force is 0. So when force is 0, that means acceleration also be 0, acceleration also be 0. So force is 0, acceleration is 0. Force increases, acceleration will also be increased. That is directly proportional. That is constant ma. That is the second law of Newton's. Second law. That's enough from my side. Now I will discuss how is Newton's third law derived from first law. My dear students, can you hear me?
Yes, sir.
So from first law, it is not force. Uh, according to first law, summation of force, that means net force equal to zero. That means if any body, any system, think that that is the system, and this body apply force on this, and this body apply force on this. So this is the F1 force, and this is the F2 force. So the total system, but the system, it is the total system. This system, if the total net force zero, that means net uh, force of the system, according to first law, net force of the system is zero. That means F1 plus F2, there are two forces are applied on the system, that is zero. That means F1 equal to minus F2. That is the third law. Am I right? This is the
Yes, sir.
third law. Third law. Okay. So that's enough from my side. Thank you so much. I will discuss my next question. What is the limitations of Newton's law of motion? You will read in your book, that is the very tiny particle, but the main thing, whose velocity is near about, I mean, the answer is hmm, when the velocity of the body is very high, and near about very high, or when the velocity of the body is near about the velocity of light. In that case, Newton's law will not be applicable. এটা তোমরা বড় হলে আরো বিস্তারিত জানতে পারবে। তো এতটুকুই ফ্রম মাই সাইড। তোমাদের যদি কোনো কোশ্চেন থাকে তোমরা একটু দয়া করে দেখে নেবে, অন্য কোথাও থেকে, সেটা তোমাদের মর্জির উপরে ডিপেন্ড করবে। So now my next question is, what is called gravitational field? It is not related to this chapter, but in your book there is given gravitational field. It is related to chapter 6 in your book, but in this chapter also it is given here. So gravitational field, what does it mean? That means if you place an object, think that this is the object 1000 kg, 1000 kg, the region where the this region where the influence of this object, we may write here the region where the influence of this body A existed is called a gravitational field. Gravitational field. Field. That's all. Uh, this is the field created by the object. Field. What is the field here? This P Q R S. PQRS is the field created by the body A. Body 100 kg, 1000 kg. That is the gravitational field. Now, what is the gravitational field intensity? What is the gravitational field intensity? Gravitational field intensity is the gravitational field intensity. Think that this is the body uh, field created by the body A, and this is the field created by the body, and the point P, and here is another point Q. So when you place a 1 kg object here, 1 kg object, if you place 1 kg object here, it will be felt, it will experience a force towards the body A, because the every body in the universe attract each other, and A will also experience force due to the presence of 1 kg object here. So how much force felt by the 1 kg object in the point Q? It is the thing that it is felt by, it is the 1 kg object, for 1 kg object felt 20 Newton of force. So that's why the intensity of this point is 20 Newton per kg. But if you place the object here, if you place the object 1 kg here, then it will feel more force because the distance is less. It will feel more force. That's why the intensity of this point will be different from this, and it will be greater because it is nearer to the object. Think that 30 Newton per kg. So, what will be the definition of gravitational field intensity? That is force felt by unit mass uh, to okay, you may draw. This is the field created by the object A, and this is the point P. So the definition is force felt by 1 kg object when it is placed uh, at a point inside the gravitational field is called uh, gravitational field intensity. Gravitational field intensity of that particular point, of that particular point. So if you place mkg object feels F Newton of force, so 1 kg object feel F by m. So gravitational field intensity E will be F by m. That is enough from my side. Do you understand, my dear students? Anything question regarding this?
No, sir.
Thank you so much. You're very good. You're responding. So, what is the unit of gravitational field intensity? Gravitational field intensity. The unit of gravitational field intensity is, since the uh, gravitational field intensity E equal to force divided by mass. So its unit will be Newton kg. That means Newton per kg. Right? That is the unit of gravitational field intensity. And it is just similar to electric field intensity. What was the electric field intensity? Newton per coulomb. That means intensity uh, F divided by Q. Q is the here charge. It is the charge carrier charge. It is not field creating charge. Okay, it will be discussed elaborately in chapter 6. Now, an mathematical problem it is given here. Uh, Mathematical problem. A 2200 kg object feel a force of 1000 Newton at a place in the space. Remember, in the space. It is not on the Earth surface. What is the gravitational field intensity of that particular point? So we know the electric field intensity is force per unit mass, force felt by per unit mass. So that is the 1000 Newton divided by 200 kg. I mean 5 Newton per kg. That is the very simple math for you. And now I'll go another topics, and it is the main things I think, but it is also discussed in your previous chapter 3. Angular motion. Define angular motion. Okay, do you need more discussion about angular motion? You need Mr. Hafiz, Nafiz, do you need?
No, sir.
Okay, because it is discussed in my previous chapter. Just angular motion is nothing but the if a body uh, rotate, if a body rotate in circular way, keeping think that it is the distance center O, keeping the same distance always, same distance, maintaining same distance. If it rotates in such a way that it always maintain the same distance from the center, that is called the angular motion. And angular displacement, it is indicated by theta. In your previous class, previous chapter, it is discussed. uh, think that object is here, and after sometimes uh, it is moving in this circular way. Sometimes it is situated in this place. So what is the angle created by the object uh, in the center? That is the angular displacement. That is the angular displacement. And in this case, what is the linear displacement? You probably you know, this is the linear displacement. This is the linear displacement, and it is the r, radius r. So angular displacement is indicated by theta, where linear displacement is indicated by s. And angular velocity, what is angular velocity? Distance per unit time. Angular displacement per unit time. Think that the body travels from A to B, and time needed after time t second. So in t second, traveling distance theta. So in 1 second traveling distance theta by t, that is the angular velocity. It is angular velocity. Angular velocity is indicated by omega. It is not w, omega. So omega equal to theta by t, theta by t. And what is the unit of angular velocity? There are too many angular unit. I mean, you may consider there are several forms of units are there. So what are the units? Can you tell me? Radian per second. So unit will be radian per second. That may another unit is revolution per second. Another is revolution per minute. Another unit is cycle per minute per second. That is hertz. Another unit is hertz, ACRTZ, etc. There are too many forms of units are there of angular velocity. It is discussed also in your previous chapter. Now, what is angular acceleration? It is angular acceleration. Angular acceleration. Uh, think that body from here to here, it is moving. It is moving, and acceleration. That means initial angular velocity omega naught, and final After time t second, the angular velocity becomes t. So in time t second, the change of angular velocity is omega minus omega naught. So in 1 second, the change of angular velocity is omega minus omega naught divided by time. So angular acceleration is alpha minus omega naught divided by time. That is the angular acceleration. Okay, in calculus form, how can you write that is the d omega by dt. That is omega, or omega minus omega naught by t. It is also discussed in your previous chapter. That's why I discussed briefly here. Angular force. What is angular force? There is a difference between the linear force and angular force. Uh, that means, what does the force do? Can you tell me, anybody here? Force can create acceleration. So if you apply force here, that is the linear force. But in the case of angular motion, this force will be termed as angular force, and that will be torque. That will be torque. It is indicated by tau. It is tau, torque. It will be discussed in next class. Tau. That is torque. I mean, you will write here angular force QE, torque, and it is indicated by tau. Angular momentum. There is linear momentum and angular momentum. Linear momentum P, but angular momentum is indicated by L. Angular mass. What is the things? Angular mass. Mass is two types: linear mass and angular mass. You may feel very astonished. You become astonished hearing the term angular. Yes, it is mass different. When a body rotates in a circular path, your mass will be changed. But in class 6, in class 1, 2, 3, 4, you learned that mass always remain constant. That is, think that 10 kg mass. But when it rotates in a circular path, the mass will be changed. And that change mass will be termed as angular mass, or it is also called moment of inertia. Moment of inertia. Okay, it will be discussed later. Relation between linear quantity and angular quantity. Okay, so I need much more space here. Mr. Nafiz. Mr. Nafiz, can you hear me? That is the linear, and that is the angular displacement. Velocity, velocity. Acceleration, acceleration. And force, uh, angular force or torque. Momentum, angular momentum. So how can you make relation? This is equal to this, equal to this, equal to this, equal to. So you have to put very fantastic here. If you place r here, is equal to r theta, r here, then but here you have to place r here, r fr, or this side, this side. This r is the radius, right? Radius of the circle. Mr. Nafis, Mr. Nafis,
স্যার লাস্টেরটা কোনটা স্যার? মোমেন্টামেরটা স্যার?
the momentum. It is angular momentum equal to PR, linear momentum into radius. Linear force into radius equal to angular force, that is the torque. Again, another thing, mass, linear mass and angular mass. But here you have to multiply, here you have to multiply radius square. That is, I will discuss also in this term in my next class. That is the, now I will discuss, compare the equation, compare the equation, compare the equation. So first of all, v equal to u plus at. But in the case of angular motion, omega equal to omega naught plus alpha t. That is s equal to u plus v by 2 into t. Am I right? Equation number 2. That is theta equal to omega naught plus omega divided by 2 into t, into t. That is s equal to another equation, s equal to ut plus half at square. It will be termed as theta equal to omega naught t plus half into alpha t square. Another v square equal to u square plus 2as. It will be termed as omega square equal to omega naught square plus 2 alpha theta. Again, f equal to ma, right? You know, in class SSC section, f equal to ma. So in this case, tau equal to tau equal to m equal to I alpha, because you know the term moment of inertia and mass is related to same thing in the case of the things which is mass in the case of linear motions, and that is the moment of inertia in the circular motion. So m will be used in the moment linear motion, but I will be used in the linear motion. So that's from my side. How can you enjoy my class? Please give me some feedback. One or two people, I will give you more lecture about what is moment of inertia, etc., and very moment what is called radius of gyration, etc., in my next class. So please give me feedback, Mr. Mahim or Mr. Akib, please.